Hi everyone, this is Subramanyam, Mathematics Faculty, Narayana Group. Already 7 questions are completed in this shift. The 8th question is, let f of x is equal to mod sin x upon x when x is not equal to 0, 1, x is equal to 0. Then total number of critical points in the interval minus 2 pi comma 2 pi they asked. The question is related to the continuity and differentiability and also differentiation, because here the total number of critical points they asked. The total number of critical points they asked means definitely here critical points definition. First we need to recall the critical point definition. The critical points means where the derivative of the function f of x is 0 and the derivative does not exist, commonly known as the critical points. So first of all, we are going to check the differentiability concept here. The given function f of x is equal to mod sin x by x when x is not equal to 0 and 1 when x is equal to 0. First, to check the differentiability, here we have one property, that is mod g of x is non-differentiable if g of x is equal to 0, and where the g of x is equal to 0 gives all those are the doubtful points for the differentiability. So in the case of in this problem, g of x is equal to sin x by cos x. G of x is equal to sin x by cos x. So sin x by cos x is equal to 0. It implies sin x is equal to 0. So the doubtful points are x is equal to 0, comma, pi, comma, minus pi are the doubtful points. At these points, the function may not be differentiable. First, we are going to check at x is equal to 0, whether it is differentiable or not. If the function is not differentiable, then definitely it is one of the critical points. So, to check the differentiability condition here, first at x is equal to 0, I am going to check the function f is differentiable or non-differentiable. We have the formula f dash of 0 is equal to f of h minus f of 0 by h whenever limit h tends to 0. This is f dash of 0. F dash of 0 is equal to limit h tends to 0, f of h minus f of 0 upon h. Now this is equal to limit h tends to 0, f of h means here when x is not equal to 0, the function is defined as sin x by x. Hence, we are writing this one as sin h by h minus f of 0 becomes here f of 0 is equal to f of 0 we are going to check. F of 0 means limit x tends to 0. Limit x tends to 0 f of x, that becomes as 1 by h. Now this is equal to limit h tends to 0 sin h minus h upon h square. When we are applying the limit to this expression, the numerator and denominator takes the forms 0 by 0 form. So we are applying the L'Hopital rule. By applying the L'Hopital rule, limit h tends to 0, we are applying the L'Hopital rule, or we are using here in this case the expansion is also correct. The expansion I am using sin h expansion is h minus h cube by 3 factorial minus h upon h square. Now this is equal to limit h tends to 0, this becomes as minus h by 6 is equal to 0. This one is equal to 0. In this case, at x is equal to 0, the function is differentiable. F is differentiable, but the derivative of the function at x is equal to 0 becomes 0. By the definition of the stationary point, here x is equal to 0 is also a critical point. F dash of 0 is equal to 0. It implies x is equal to 0 is a basically stationary points. Stationary point. So x is equal to 0 is a stationary point. It is a stationary point. Stationary. Every stationary point is also a critical point. Now we are going to check at x is equal to pi and at x is equal to minus pi, whether the function is differentiable or not. It is very clear at x is equal to pi and at x is equal to minus pi, f of x is non-differentiable. You know these very well, non-differentiable. Suppose if you want to check at x is equal to differentiability, at x is equal to pi, the differentiability of the function f of x, same process what we can done in the at x is equal to 0, in the same process you try to solve the problem. Then we are getting definitely it is f of x is non-differentiable at x is equal to minus pi comma pi. So these two are also the critical points. So at these 2 points the function is not differentiable. These two are the critical points. Total 3 critical points here. Now f dash of x is equal to 0. We are going to find out f dash of x is equal to 0. That is f dash of x is equal to, we are differentiating with respect to x, sin x by x. Sin x by x. Now the derivative of sin x by x, using the u by v rule, we are writing this one as x squared x cos x minus sin x. So f dash of x is equal to 0. It implies x cos x minus sin x is equal to 0. From this, tan x is equal to x. Tan x is equal to x. F dash of x is equal to 0 means tan x is equal to x. Now, how many solutions it has in the interval minus 2 pi to plus 2 pi? That we are going to check. That is, by using the graph, we get this one. See there? I am going to draw the graph of tan x is equal to x graph. In the interval 0 comma 2 pi interval, I am going to draw. This is pi, and suppose this is pi by 2. Next 3 pi by 2 and 2 pi. This is 2 pi. Now the tan x graph is, you know that how we are going to draw the tan x graph means like this one. Like this one. Now by drawing y is equal to, here we are going to draw the graphs of y is equal to tan x and y is equal to x. Y is equal to x line. This is y is equal to x. Therefore, tan x is equal to x has a solution in one solution in 0 comma 2 pi. Similarly, by the symmetricity of the function, because this function is a symmetric function, observing f of minus x is equal to f of x. F is a symmetric function. F is a symmetric function. F is a symmetric function. Hence, there exists one more root for tan x is equal to x. One has one solution. In the interval 0 comma minus 2 pi. Therefore, f dash of x is equal to 0 has two solutions in minus 2 pi comma 2 pi interval. Hence, the total number of critical points, total number of critical points is equal to, first 0 is 1, plus pi and minus pi are the critical points 2. Here f dash of x is equal to 0. F dash of x is equal to 0 has 2. Total 5 critical points the function. The problem contains multiple concepts. Definitely it is somewhat lengthy problem, and the differentiability checking and also the derivative of the function must know the student. Then only he can handle this problem. Next.